Okay, so now that you all know how to write and name chemical compounds, we are almost to the point where we can actually get into chemical reactions, okay? Before we do that, we have to learn one last thing, which is how to write and balance a chemical equation. Basically, a chemical equation is the way that we can represent a chemical reaction, and we're going to do this in a series of letters and symbols representing the reaction that's taking place. So we're going to take a look at a couple examples and see how you do this. Let's take, for example, the example of oxygen reacting with carbon and wood to form carbon dioxide. Okay, so we're going to take those words, we're going to convert them into symbols. So here we have O2, that's oxygen, and of course it's a gas, plus C for carbon, and if it's in wood, that means it's a solid. And we have a little arrow here, and then carbon dioxide, and of course carbon dioxide is a gas. Some vocab for you: anything on the left side of the arrow, these are called reactants. That's kind of what goes into your chemical equation, kind of your ingredients, if you will. And anything on the right side is a product, okay? This is what is made in the chemical reaction. We can use a plus sign to separate any reactants, and if we have multiple products, we would use a plus sign in between them. This arrow here means yields, forms, produces. This is what you make in the thing. And then here, if we have a gas, it's a G, and a little S is a solid, and L is a liquid, and AQ is aqueous. That means it's solution dissolved in water, okay? So we always want to, these are state of matter symbols. We always want to, wherever possible, include state of matter symbols representing exactly what's going on here. Here's another example. Solid lead reacts with oxygen in the air to produce solid lead 2 oxide. Okay, so let's start. Here we go. First we have to find out that lead's symbol is Pb. It's one of the weird ones. Okay, so and it's solid leads. We put a little S here, and we would put a plus in between our reactants, and then we've got oxygen, O2, and then we have a little G for gas, and it's going to make solid lead 2 oxide. Okay, lead 2 means it has a charge of +2. Oxygen has a charge of -2. Oh, that's nice. They go together evenly, so it's PbO. So there's our product. And now if we put it all together, solid lead plus oxygen gas yields or produces lead 2 oxide, and that's solid. There we go. All right, so now we have officially written that chemical equation. Next, we're going to learn how to balance a chemical equation. Maybe you've heard the saying, matter can't be created or destroyed, and this is true. So basically what it means is you can't make something from nothing. It basically means that Harry Potter isn't possible, right? We can't just point a wand and something appears out of thin air, and we can't just point a wand and something disappears out of thin air. And so I'm going to show you how this applies to chemical reactions. Let's take that first example that I made. So I've got my reaction that we already wrote of oxygen plus carbon makes carbon dioxide. And now we're going to see if it's balanced. Well, what does that mean? I want to make sure that I haven't randomly created or destroyed matter. So over here, this O2 means I have 2 oxygens. So if I put 2 oxygens into my reaction, I should get 2 oxygens out. And so if I look on the right side, oh, look at that. I get 2 oxygens out. Great. Perfect. I'm going to check my carbons. I put 1 carbon in, I get 1 carbon out. Great. That means this equation is balanced. I haven't violated any laws of the universe, and everything is good to go. Sometimes when you write chemical equations, they are balanced as written. Those are really great ones to get. But sometimes, however, they are not balanced as written. Okay? Here's an example of one. If this is a way you can make water, if you take hydrogen gas and oxygen gas and you make water. So first our equation would be H2 gas plus O2 gas, and there we've got our little arrow. Here's our product, water, and of course water is a liquid. And so now I'm going to make sure that it's balanced, that I haven't like Harry Pottered anything, made something out of nothing. So I look here, H2, 2 hydrogens on the left side, H2, 2 on the right side. Good. O2, I've got 2 oxygens on the left, and uh-oh, I only have 1 oxygen on the right. If I put 2 in, somehow 2 has to come out because it just doesn't disappear. Where did it go? It doesn't, that's not possible. Okay, so now I'm going to need to balance it. One thing to remember when we're balancing the equation, we are not going to change the little subscripts, okay? So I cannot just go behind oxygen and put a little 2 here because that makes H2O2, which is actually hydrogen peroxide. It's something totally different. It's not water, okay? So I cannot go back and just put a little 2 there behind my oxygen. No, 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 can't do that. So when we are balancing an equation, you can only change the coefficients. Coefficients are numbers in front of a formula, and I'll show you what that looks like in a second. So we're going to add numbers in front, but we cannot change the numbers behind, okay? So here's what this would look like, okay? Here's my original one. And if I put 2 oxygens in, that means I have to get 2 out on the right. So the way I can do that is I can add a coefficient of 2 in front of the H2O. So this means instead of making 1 water molecule, I'm making 2 water molecules, okay? So great, now I have 2 oxygens on the left, and this 2 multiplies to everything behind it. So now I have 2 times 1, 2 oxygens on the right. Perfect. But some of you may have picked up on something. If this number applies to everything behind it, this number also applies to the hydrogens. So now I have 2 times 2. I have 4 hydrogens on the right side because I have 2 water molecules, right? And if you have, it's H2O, so there's 2 hydrogens in one and another 2 in the other, so that's 2 plus 2 is 4. I have 4 hydrogens. Ugh. I have 4 hydrogens on the right now and only 2 on the left. Oh no. So now my hydrogens are unbalanced. By fixing the oxygens, I now messed up the hydrogens. So what am I going to do? I'm going to go back. I'm going to put a coefficient of 2 in front of the hydrogens. So now I have 2 times 2, 4 hydrogens on the left, 2 times 2, 4 on the right, 2 oxygens on the left, 2 times 1, 2 on the right. So now everything is balanced. I have now made sure that the laws of physics in the universe are being obeyed, and we're not creating something from nothing and nothing is disappearing. So that is how you balance this chemical equation. Back when I was writing these equations and it was like H2 and O2, and it just said hydrogen gas and oxygen gas, like, how did I know it was H2? How did I know it was O2? The name doesn't say that, it just says hydrogen. Well, as it turns out, hydrogen and oxygen are what we call diatomic elements, okay? And what that means is that they are never anywhere alone. They will always, always, always be in a pair, okay? And basically, these are some nonmetals. So we have hydrogen, oxygen, nitrogen. They're always come in pairs, so H2O2, N2. And then all of the halogens, group 7. All of these always come in a pair. So if you ever see fluorine reacts with such and such, it's F2. Nitrogen reacts with blah, 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 it's N2, okay? So these are the diatomics. You will need to memorize these. So whenever you see that word written out, you know that when you're writing the formula that you need to have a little 2 subscript behind it, okay? So that's an overview about how to write and balance chemical equations, and we will be doing several days of practice with this in class so that hopefully you'll get really good at them.